Imagine sending a message in a bottle into the vast ocean, hoping one day it reaches a distant shore. Now imagine that bottle is a spacecraft, and the ocean is the infinite expanse of space. This is the story of Voyager, humanity's most daring exploration of the unknown.
In 1977, two spacecraft, Voyager 1 and Voyager 2, were launched to explore the outer planets. But what happens when a spacecraft goes beyond the edge of the solar system? What secrets lie hidden in interstellar space? These are the questions Voyager would one day help us answer. Voyager 1 and 2 were built to be explorers. Their first mission was to visit the giant planets, Jupiter, Saturn, Uranus, and Neptune. They sent back breathtaking images of these worlds, showing us volcanic moons, stormy atmospheres, and icy rings in stunning detail. But Voyager's journey didn't stop there. Each spacecraft carried a special message, a golden record with sounds and images of life on Earth. These records were designed to communicate with any intelligent life that might someday find them, making Voyager an ambassador of our planet. Long after completing their primary mission, Voyager 1 and 2 kept going, traveling further than any human-made object in history. But leaving the solar system isn't as simple as crossing an invisible line. At the boundary lies a mysterious region, the edge of the heliosphere, where the sun's influence ends and interstellar space begins. What did Voyager find at the edge of this cosmic bubble? What mysteries awaited in the darkness beyond? The answers it sent back would change how we understand our place in the universe. When Voyager 1, one of humanity's most remarkable space probes, approached the edge of the solar system, scientists were expecting a relatively smooth transition into interstellar space. But what it found was far more mysterious. A strange, unexpected zone known as the Stagnation Region. The Stagnation Region is where the solar wind, the constant stream of charged particles blowing outward from the sun, suddenly slows to a near standstill. Instead of flowing outward like it does in the rest of the solar system, the solar wind appeared trapped, unable to escape further into space. Think of the heliosphere as a giant bubble created by the sun's solar wind, which shields our solar system from much of the radiation and cosmic rays in interstellar space. Voyager 1 revealed that, in the Stagnation Region, this bubble begins to break down. Solar wind particles pile up, creating a dense, chaotic zone where the sun's influence starts to fade. This discovery was completely unexpected. Scientists had assumed the transition into interstellar space would be sharp and abrupt, like stepping through a doorway. Instead, they found this sluggish, turbulent area where solar wind and cosmic rays interact in unusual ways. In the Stagnation Region, not only does the solar wind grind to a halt, but cosmic rays from outside the solar system, high-energy particles traveling through interstellar space, start to flow inward more freely. It's like watching two opposing forces collide, creating a cosmic tug-of-war. Voyager 1 measured these interactions using its onboard instruments. It detected a dramatic increase in particle density and shifts in the magnetic field that were unlike anything seen before. These measurements helped scientists map the outer edges of the heliosphere for the first time. The Stagnation Region showed us just how complex the boundary of our solar system really is, explains a NASA physicist. It's not just a simple bubble. It's a dynamic, evolving region that challenges everything we thought we knew about the heliosphere. The Stagnation Region wasn't just a curiosity. It changed our understanding of how the sun interacts with interstellar space. It revealed that the boundary of our solar system isn't a hard line, but a vast, chaotic frontier where the sun's influence battles the forces of the galaxy. Voyager 1's journey through this mysterious zone was a turning point in space exploration. It showed us that even at the edge of the solar system, The sun's reach is far more complex and fascinating than we ever imagined. When Voyager 1 set its sights on interstellar space, scientists expected a smooth transition, a crossing from the magnetic influence of our sun to the magnetic fields of the galaxy beyond. They imagined it would be like stepping from one room to another. But what Voyager found was something far more puzzling. Before Voyager's historic journey, scientists believed that the sun's magnetic field would slowly fade away and give way to the magnetic field of the Milky Way. This transition was expected to be clear and distinct, a sign that Voyager had finally crossed into true interstellar space. But reality defied expectations. As Voyager crossed the heliopause, the boundary where the sun's influence ends, the magnetic field direction didn't change as predicted. Instead, it remained aligned with the magnetic field within the solar system, almost as if the sun's magnetic influence was stretching farther into interstellar space than we thought. This unexpected discovery left scientists scratching their heads. Voyager detected that the magnetic field in interstellar space was still closely aligned with the sun's magnetic field, even outside the heliosphere. Rather than the sun's magnetic field fading abruptly, it seemed to blend and interact with the galaxy's magnetic field in a way no one fully understands. It was as if the sun's magnetic bubble wasn't just a shield but a dynamic system, pushing and pulling against the forces of interstellar space. This discovery isn't just a scientific curiosity. It's a clue to how our solar system interacts with the galaxy around it. The sun's magnetic field doesn't just stop at the edge of the heliosphere. It appears to influence interstellar space in ways we're only beginning to uncover. Understanding this interaction could help us better understand how our solar system is protected from cosmic radiation, which bombards interstellar space at all times. It also raises questions about the boundaries of other star systems. Do their magnetic fields behave the same way? To understand this phenomenon, let's compare it to something closer to home: Earth's magnetic field. Like the heliosphere, Earth's magnetosphere acts as a shield, protecting our planet from the sun's charged particles. But where Earth's magnetosphere deflects solar winds, the heliosphere deflects galactic radiation. Yet, unlike Earth's shield, the heliosphere's boundary is far more complex, constantly shifting and interacting with forces from beyond our solar system. This means that the sun's magnetic influence may extend farther than we imagined, shaping how our solar system is affected by the vast galaxy we inhabit. Voyager's unexpected findings remind us of how much we still have to learn. The magnetic field orientation mystery isn't just about the edge of the solar system. It's a window into the forces that shape our place in the universe. As Voyager continues its journey deeper into interstellar space, it carries with it the potential to uncover even more surprises, challenging our understanding of how the sun and the galaxy interact. When Voyager 1 crossed the heliopause in 2012, it officially left the protective bubble of our sun's influence, entering interstellar space. But what did it find in this vast, uncharted region? Using its onboard plasma wave instrument, Voyager uncovered something unexpected: sound waves that told us an incredible story about interstellar plasma density. Voyager's plasma wave instrument is like an interstellar eavesdropper. Instead of directly seeing plasma, it listens to the vibrations caused by charged particles in space. When these particles interact with waves in the plasma, they create faint signals that Voyager can detect and send back to Earth. In 2012, after crossing the heliopause, the boundary where the sun's solar wind ends and interstellar space begins, Voyager detected a distinct hum. These vibrations revealed the presence of interstellar plasma, a soup of charged particles spread thinly throughout space. But the surprises didn't stop there. Years after crossing the heliopause, Voyager began detecting strange changes in the plasma density. In some areas, the plasma was denser than expected. Scientists believe this happens because interstellar plasma is influenced by distant shock waves from our sun, like solar flares and coronal mass ejections. These shock waves ripple out, pushing against the plasma even beyond the heliopause, causing sudden fluctuations in its density. This was a groundbreaking discovery. Interstellar space isn't as uniform as we once thought. It's a dynamic environment shaped by the sun, even at distances over 14 billion miles away. To understand how interstellar plasma differs from the solar wind, let's compare the two. Inside the heliopause, the sun's solar wind dominates. It's a fast-moving stream of particles emitted by the sun, creating a bubble called the heliosphere. Beyond the heliopause, however, solar wind particles can no longer escape the sun's gravitational pull. Instead, Voyager entered an entirely new region filled with interstellar plasma. This plasma is much denser but moves more slowly than solar wind. It's also colder and more stable, creating an environment that feels eerily quiet compared to the chaotic, fast-paced solar wind. So, why does this matter? The data Voyager collected about interstellar plasma density is more than just a scientific curiosity. It's a critical roadmap for the future. Imagine a future spacecraft following Voyager's path into interstellar space. By understanding how plasma density changes beyond the heliopause, we can better prepare these probes to handle the unique conditions of interstellar travel. For example, knowing where plasma density is highest could help engineers design instruments that won't be overwhelmed by these particles. The plasma wave instrument also taught us that listening to space can be just as valuable as seeing it. Future probes might use more advanced versions of this technology to gather even clearer data about plasma and other invisible forces shaping the universe. Voyager's journey into interstellar space reminds us that even the emptiest regions of the cosmos are alive with energy, sound, and discovery. And while it's over 14 billion miles from home, its data continues to teach us about the forces shaping the space between stars, inspiring future explorers to follow in its path. At the edge of the solar system, Voyager crossed into a realm unlike any it had encountered before. Beyond the protective bubble of the sun's influence, the spacecraft faced a strange and relentless force: cosmic rays and the interstellar wind. Cosmic rays are tiny, high-energy particles zipping through space at nearly the speed of light. They come from supernovae, exploding stars, and other violent cosmic events across the universe. While the sun's magnetic field shields us from most cosmic rays within the heliosphere, Voyager's journey beyond this protective barrier revealed just how intense they can be. As Voyager crossed the heliopause, the outer edge of the sun's bubble, it detected a sharp increase in cosmic rays. In just a matter of days, the number of these particles surged, proving it had truly entered interstellar space. But Voyager didn't just detect cosmic rays. It also felt the interstellar wind, a slow flow of particles drifting through the space between stars. These particles, mostly hydrogen and helium, are remnants of ancient stars that died billions of years ago. Unlike the fast-moving solar wind within our solar system, the interstellar wind is more like a faint, steady breath of the cosmos. Voyager's instruments detected this movement as it passed into the vast expanse of the interstellar medium, giving scientists their first close-up glimpse of this mysterious space. This harsh environment poses new challenges for spacecraft. Beyond the heliosphere, there's no magnetic shield to block cosmic rays. Instead, spacecraft like Voyager are constantly exposed to intense radiation. cosmic rays don't just damage electronics over time, they also pose a significant threat to astronauts. Understanding these conditions helps us design better shielding for future missions into deep space. Studying Voyager's data has been vital for planning future interstellar probes and missions that might one day take humans beyond our solar system. Every reading from Voyager teaches us how to navigate and survive in this dangerous environment. The cosmic rays and interstellar wind Voyager has encountered reveal not only the challenges of space exploration, but also the awe-inspiring power of the universe. This tiny spacecraft, billions of miles from home, is giving us a glimpse into the forces shaping the vastness of interstellar space. Voyager's discoveries remind us that even in the emptiest parts of space, there's a story waiting to be told. After more than 45 years, Voyager 1 and 2 are still alive, sending whispers from the edge of the solar system. But how are they still running after all this time? The Voyagers were designed to last, but even their resilience has limits. They run on power generated by small nuclear batteries, called radioisotope thermoelectric generators. These batteries convert the heat from decaying plutonium into electricity, but over time, the power output has been steadily decreasing. To conserve energy, NASA has had to shut down non-essential systems, like some scientific instruments and heaters. Today, the Voyagers operate on less power than a refrigerator light bulb, yet they continue to send data from billions of miles away. Even with minimal power, Voyager is far from silent. Its instruments are still collecting valuable data about interstellar space, the vast region beyond the influence of our Sun. Through these signals, Voyager has measured the density of interstellar plasma, revealing how space between the stars isn't as empty as we once thought. Each piece of data helps scientists better understand the boundaries of our solar system and what lies beyond. But time is running out. By the mid-2030s, Voyager's power supply will likely be too weak to send data back to Earth. When that day comes, these spacecraft will fall silent, drifting endlessly through the galaxy. Even when Voyager's voice fades, its journey will continue. These spacecraft are on trajectories that will take them beyond the reach of any human influence. Voyager 1, in particular, is heading toward the star Gliese 445, though it won't arrive for another 40,000 years. In a way, Voyager represents humanity's legacy in space. Long after Earth is gone, whether from natural causes or humanity's own hand, these spacecraft will continue to travel, carrying the story of who we were. Each Voyager carries a golden record, a message in a bottle for the universe. These records contain sounds and images from Earth, a snapshot of life as we know it, music, greetings in dozens of languages, and the heartbeat of a human being. It's a gift to any civilization that might one day find it. What does it mean that our first steps into interstellar space will outlive us? The Voyagers remind us of the fragility and impermanence of life on Earth. Yet, they also symbolize our hope, curiosity, and determination to understand the cosmos. They carry more than just data. They carry humanity's desire to explore, to dream, and to reach for something greater. In the end, Voyager's journey is not just a scientific one, it's a testament to the enduring spirit of exploration. Voyager's journey has taught us more than we could have ever imagined. It crossed into the Stagnation Region, where the solar wind slows and cosmic rays begin to build up, giving us a glimpse of the mysterious boundary between our solar system and interstellar space. It revealed puzzles about the magnetic field beyond the heliopause, a region where our sun's influence ends, yet strange alignments of magnetic forces remain. Voyager also detected interstellar plasma, waves traveling through the vast void, carrying the echoes of a space untouched by our sun. And let's not forget the cosmic rays it measured, particles from deep space that tell us about the violent, energetic events shaping our galaxy. Even now, Voyager continues its mission, sending data from over 14 billion miles away, proving its resilience and value. But what's next? Will Voyager's discoveries inspire new missions to explore even deeper into interstellar space? Concepts like NASA's interstellar probe are being imagined, aiming to venture even further than Voyager, uncovering the secrets of our galactic neighborhood. As technology advances, so too does our ability to reach beyond what once seemed impossible. Voyager's journey is more than a mission. It's a story of human curiosity, determination, and wonder. It reminds us how small we are in the grand scale of the cosmos, yet how far our reach can extend. As it continues its silent journey into the void, it carries with it a simple yet profound message. We were here, and we dared to explore.